Planetary orbits around a single star are predictable and stable. Though our sun is actually moving through the Milky Way at a speed of about 514,000 miles per hour with the rest of the solar system, our sun appears motionless to us. This makes calculations of where an object in orbit is predicted to go relatively easy, as they all travel around it. As we add another star to the system, it gets a bit more complicated. In time, however, the two stars will fall into stable orbits and revolve around a fixed point, called the barycenter. Once that happens, the path of bodies orbiting the binary system become predictable, and fall into an orbit known as a p-type, or circumbinary orbit. However, this predictability disappears when we add a third sun to the mix. With three bodies orbiting each other in space, orbits become dynamic and chaotic. The problem was first considered by Isaac Newton, who struggled to apply his laws of motion and gravitation to the interactions of the Earth, Sun, and Moon. Even now, it has no definitive solution and is known as the three-body problem in celestial mechanics. As it turns out, the number of potential variations in such a situation is non-repeating and can't be accurately predicted, though proofs of potential stable orbits have been calculated. Living in a system with three suns would be chaos, but is it possible in the first place? Although it's easy to assume that multi-star systems are rare since we live in a single star system, that's not the case. And triple star systems are actually especially common. In 2016, a team of researchers from the University of Arizona discovered a planet orbiting three stars. Named HD 131399AB, the planet takes 550 Earth years to orbit its suns. For much of this time, the stars appear close together, meaning that the planet has 3 sunrises and sunsets a day. However, for 140 Earth years, the setting of one sun coincides with the rising of another, bathing it in almost constant daylight. The system seems stable, but the only way to know if it's sustainable in the long term is to continue watching it. The only reason the exoplanet doesn't spin out of the system is because it orbits one star in particular and is 300 astronomical units from the other two. For context, 1 astronomical unit is roughly the distance from the Earth to the Sun. However, if our solar system had 3 suns, it'd be a different story. A lot would depend on their orbits. The average distance from our Sun to the furthest planet in our solar system, Neptune, is only 30 astronomical units. If the stars were all in orbit at the center of the solar system, the combined heat would quickly scorch our planet. Seeing 3 sunrises in the sky might sound exciting, but it'd be considered a bad omen because of the extreme heat that would follow. We could be hit with 3 times the normal amount of heat, far more than necessary to end life as we know it. In fact, an increase of just 10% in our own sun's luminosity, expected to occur in 1 billion years, is enough heat to turn Earth into a second Venus. Even if there was enough space between Earth and the other suns to avoid this, living on Earth could quickly become impossible. For part of the year, we might live in constant daylight, completely changing our concept of time. Seasons would change and become unpredictable. Our survival would depend on the 3 stars settling into stable orbits, although even this might not be sustainable in the long term, given the unpredictable nature of multi-star systems. If a star ever swung too close by, tidal forces could rip our planet apart. Meanwhile, the orbits of the planets in our solar system would be thrown into complete chaos. Our planets have stable orbits because they orbit a single massive body, the Sun. With 3 suns and 3 massive points in space constantly changing their positions, all of these orbits would be disrupted. They'd also likely be drawn closer to the center of the solar system and its 3 suns. The reason that the planets don't fall into the Sun is because of the speed at which they orbit, but that could change if multiple suns pulled at them from even slightly different directions. If any of our planets were to slow sufficiently, they'd fall towards the suns, to be engulfed and disintegrated. Such might be the eventual fate of all of our planets, caught in the midst of an unpredictable and chaotic gravitational tug-of-war. If our species was fortunate enough to be in a habitable condition for a time, we'd be obsessed with trying to calculate the stars' orbits. If we could accurately predict the future positions, we might be able to work out how much longer we had to survive. But because orbital trajectories are essentially non-repeating in a 3-body system, we may never find out how to predict their next positions and be forced to live in constant fear. Stability would be one of the possibilities, but long-term instability would be more likely. If at any point Earth was drawn out of its new and shifting habitable zone, it would either freeze or burn as temperatures overcame it. If we lost our orbital speed, we'd be destined to fall towards the suns and disintegrate, or we might just get spun out of the system entirely. Our planets could even crash into each other, a potential scenario when our sun goes red giant. Even if we could only closely pass by another planet like Jupiter, it could be close enough to drag our atmosphere away and leave us susceptible to the vacuum of outer space. Many things could go wrong in an unstable system with 3 bodies. And that's what would happen if our solar system had 3 suns.